So last time we were studying and learning about how we can use graphing to solve a system of linear equations. And now we're going to learn another way called substitution. Now substitution is an idea we've been using in algebra from the very beginning. And it's something we're familiar with in everyday life. For instance, if I were coaching basketball or soccer and during the game I wanted to take a player out, I would substitute one player out and put in another player. And that's the idea of substitution, and we see it in mathematics all the time. So we're going to use this idea of substitution to help us solve a system of equations. Now, probably what can confuse some students is, in this case, we're substituting one thing in and we're putting one thing out, players. But sometimes during substitution, it's more like this. Let's say a watermelon has the same weight as 2 oranges and a banana. So you don't just have one thing coming in for one thing. You have watermelon coming out, and you have 2 oranges and a banana coming in, but the weight on the scale would be the same. And so that's what substitution is going to be more like. So our essential question is, how can you use substitution to solve a system of linear equations? And that's what we want to think about, is how we can use the substitution to solve when we have a system. Remember that a system is 2 or more equations that share the same variables. So this is how we would do it. Solving a system of linear equations by substitution. The first step is to solve one of the equations for one of the variables. Get a variable by itself. Substitute the expression from step 1 in the other equation and solve for the other variable, and then repeat that one more time. So we'll come back to these steps as we're working out the problem. So the first step was to solve one of the equations for one of the variables. I told you we'd come back to it. So looking at this first question, it says solve the system of linear equations by substitution. Now, it looks like it's set up for graphing because it's in that y equals mx plus b, the slope-intercept form. But remember that we're solving not by graphing, by substitution. So it doesn't really matter that it's in that form. And so what we do care about, though, is that we have one variable by itself. In this case, that's already done for us. Y is already by itself. See how it's y equals? And then the second step is, once you get one letter by itself, to substitute that expression from step 1 into the other equation and solve for the variable. So looking at the second equation, we see how there's a y. We're going to essentially take this y out, and in its place, put in what the y equals. What does the y equal? Looking at this equation, it equals a negative 2x minus 9. So we're going to rewrite this second one, 6x minus 5, 6x minus 5, so far the same, but in place of the y, we're taking the y out, and we're substituting in what the y actually is. And what is the y? Well, the y is a negative 2x minus 9. So instead of a y, I'm writing negative 2x minus 9. I want to stop for a second and make sure you see this step. If you understand this step, everything else will make sense. If you don't understand this step, you may want to rewind it and watch it a few times. But we're basically taking out the y and in its place putting in what the y equals up here. Okay, so once you do that, 6x minus 5 times, this is all the y, this whole thing is the same thing as a y, equals a negative 19. Now we just solve for x. I want you to notice what we've done, though. We had a problem that had an x and a y. We took the y out, and now we have a problem that just has has x's. There's no more y. That's great. So in other words, we had 2 unknowns before, an x and a y, and now we only have 1 unknown. Well, that's good news because we can get the answer to that 1 unknown. Let's just do that. And this is just the normal order of operations that we always follow. So we're going to do the distributive property here, bring down what we didn't use. See, a negative 5 and a negative 2x would be a positive 10x. Negative times a negative would be a positive 45. And bring down the negative 19. Collect like terms. Bring down what you didn't use. And then we're just going to solve for x like we normally would. Bring down what we didn't use. Divide. We go to the side here so we don't run out of room. X equals -4. Now that you found the answer for what x is, I'll write that here as part of an ordered pair. X is -4. We still need to find the missing y. And that kind of makes sense. So we substitute it back in. Now, you have choices here. You could substitute it back into this original equation. You can substitute it in this equation. There's even some more choices, but let's keep it simple for now. I'm going to choose to substitute it into this first one because y is already by itself and it just seems like it'd be easy to get the answer that way. So y equals -2, but in place of the x, I'm going to look down here and see what the x equals. Well, the x equals -4. Now that took the place of the x, and I'm just going to write the rest of it. -9. Y equals a negative times a negative is a positive. 8 minus 9. Y equals -1. So I found the answer without graphing by using this method called substitution. It's pretty cool. Now I could graph this as well, and I would get a very similar answer, but this is even more precise because as we saw when we graphed, unless we have a graphing calculator and graphing paper, it can sometimes be a little off, where this is completely right. We can always check our answer, though, by substituting these back into the original equation. Let me do that really quick just so you can see what it looks like. So the original equation was y equals -2x minus 9. I'm going to substitute back in a -4 and a -1. It'll be a -1 equals a -2 times a -4 minus 9. -1 equals 8 minus 9. -1, oops, sorry, equals -1. Oh, it worked out. It's true. So we know we got it right. And notice, interestingly enough, we substituted these back into the original equation to get the answer. Wasn't that what we're doing? Isn't that the name of this whole thing? It's called substitution. So you're using the same skills we were using earlier in the year. All right, here's a sample problem. It's not in the book, just to see if we understand the idea. So this one already has a letter by itself for me, y equals. So if I wonder which one should I use to put into the other one, well, since this already has a variable by itself, I'll substitute it in this one. It's just, the work's kind of done for me. So I'm going to rewrite this one, 3, but what will I put in place of the y here? Well, what is the y? We know the y is -x plus 3. How do we know that? Because right here it says y is a -x plus 3. So I'm substituting this y out, and I'm putting in this -x plus 3 in its place. And let me talk a little bit less and just work out the problem so you guys can see it. So we're just going to solve then like we always solve. -3x plus 9. Bring down the plus 5x equals -1. Collect like terms. 2x plus 9 equals -1. Oops. Subtract -9 from both sides. Or add a -9 to both sides, so we want to say that. And divide is the last step. X equals -5. You have the x, but we need to still go back and find the y. So I'm going to substitute this -5, which is the x, and I can substitute it either into this equation where the x is, or this equation where the x is. Since they're a system, the value of x in one of these equations is going to be the value of x in the other. So I'm going to substitute in a -5 up here into this equation in place of the x. So y equals a negative, and then x is a -5 plus 3. Y equals a negative and a negative, make it a positive. Y equals 8. So I have my ordered pair here. I know x is a -5. I know y is 8. I have my answer, yay, but if I want to, I can check it by substituting both of these back into the original equation. Let me do that real quick. Y equals, instead of a -x, I'm going to put a -5 in its place, to be a -5. Or if you want, that's just a +5. Plus 3. Oops, I forgot to put the 8 for the y, didn't I? So let me do that right now. 8 equals 5 plus 3, which is 8. Checks out, we get it right.